Welcome everybody. Let's talk about section 5.2 on right triangle trigonometry. And this is where we start putting together some of our geometry with some trigonometric functions that always give us ratios of sides to one another. And I'm sure that you're probably a bit familiar with it at this point, but it's worth repeating anyways. So let's just run through it. If we're given two similar triangles, we don't actually have to know all the angles or everything about that triangle in order to get the missing sides of a similar triangle. In fact, similar triangles have the particular property that ratios of sides to one another have the common values. So for example, right here, let's assume that these two triangles are similar triangles. So both of them contain the same angles, and I'm using the Greek symbol theta here to represent the angle. If this particular angle, and of course these are right angles right here, we're assuming, if all of those things are the same, then what can we say about these two triangles? Well, most certainly, if I was interested in finding this length of side x, I could tell you that the length of x divided by its hypotenuse was exactly equal to the length of 12, in this case, divided by the hypotenuse here, 12/13. And what's more, if we wanted to solve for that, that's a very easy solve for us, because all we're saying is that, well, what would give us this number if we multiply both sides by 39? We could just do a little bit of algebra right here. Multiply both sides by 39 and get x is equal to, let's see, 39 divides by 12 to give you 3. And 12 times 3 is 36. So that makes the length of side x equal to 36. And we can pull off the same trick with our opposite side right here from the angle. If we say that, well, y, the length of the opposite side over its hypotenuse 39, set that equal to the similar triangles ratio that we already know, the length of its opposite side, 5, divided by its hypotenuse. And since these two ratios must be the same for these two similar triangles, then, just like we did before, multiply both sides by 39. And through division right here, we note that y would be 13 divided into 39 is 3. 3 times 5 is 15. So our length here would have to be 15 to make this work. So similar triangles, we know how to do this. If you've ever done any studying for the algebra, we've done this in all kinds of places before. So none of this is actually new. Right triangle trigonometry is in fact the art of similar triangles. We just happen to give them different names. So we define each of these terms in terms of the ratio of the sides of the triangle. So let's give the angle a name. Let's call the angle theta. Right? We use the Greek symbol theta used typically to represent an angle. We could call it anything that we wanted to, but in this case we're going to call our angle theta. So how do we express this? Well, we say the sine of the angle by writing sine, S-I-N, we abbreviate, and of course then we write the angle's value after the sine. Now it is very important that you write sine and associate it with an angle. If you write sine without an angle, well, it's just a sin, right? And we don't like sinning here, so we're going to be very good people, and we're all going to sine the angle theta. And what it means is that it's always the ratio of the opposite side's length to the hypotenuse side length. Okay? And of course, you certainly know these other ratios right here. Let's go through the definitions just as a reminder. Take the cosine of the angle theta, and that is the ratio of the length of the adjacent side divided by the length of the hypotenuse. And these are definitions that I'm going to continue to refer to as I go along. I take the tangent of an angle theta by taking the length of its opposite side and dividing it by its adjacent side. These three basic definitions are ones that we use all the time. There are a few others that we don't use as often, but we definitely need to know. One is called a cosecant. Cosecant of an angle means that we're going to take the ratio of the reciprocal of the sine. So we're going to take the hypotenuse this time and divide it by the length of the opposite side. We're going to say a similar thing about secant, except that secant happens to be the reciprocal of the cosine function. So we're going to take the hypotenuse this time and divide it by the length of the adjacent side. And then finally, our cotangent of the angle is going to be the reciprocal, we write COT, of theta of our tangent. So we're going to take our adjacent side and we're going to divide it by the opposite side this time. So for these last three, the things to remember is that we are talking about reciprocals of our basic three trigonometric functions. So if you keep them in mind this way, this will be really, really helpful whenever we have to deal with our trigonometric functions, our 6 trigonometric ratios, and make them really, really easy to get all of these ratios very easily. Okay, so having given these definitions, let's just go through a really quick example. Let's say that I was dealing with my triangle that had 5, 12, and 13 and this angle theta. Well, then anytime I run into a similar triangle, I can use these ratios all the time. So I would say that the sine of this angle theta was 5 over 13. That's what we used to find our side y in the last example, the first example that I gave. If I was interested in the cosine of the angle theta, I'm taking the ratio of my hypotenuse to my adjacent to my hypotenuse side, so I'm going to have 12 over 13 in this case. If I want to write something about the tangent of my angle theta, I'm going to take the ratio of my opposite to my adjacent side, and then I'm going to go for my reciprocal. So I would define cosecant of theta in this particular case to be, if sine is 5 over 13th, cosecant is 13 over 5. It's reciprocal. The reciprocal of the cosine is secant of theta. So we define it as the reciprocal being 13 hypotenuse over 12 adjacent. And then finally, tangent has its reciprocal function of cotangent of theta. And cotangent of theta is going to be the ratio 12, the adjacent side, over 5, the opposite side. Okay, we'll develop some more in the next few videos.